is just the foundation detail for this class period. So one of the things I want you to take into account is what happens when a floor, in this case, the foundation, meets a wall. So whenever you have a concrete wall meets at a brick edge, you have what's called a brick ledge. A brick ledge is what the brick sits on whenever the building is built. Now the brick sits lower than the actual wall height. So if you're looking at the brick ledge, this is what a brick ledge is. It's connected directly to the foundation. Monolithic pour. I want you to take a look at that. If you ever walk around the site and you see something like this, this is called a brick ledge. This is what the brick will sit on, right? The brick doesn't sit flat on the ground because the brick needs to be supported too. Brick by nature is very unstable when it's placed directly on soil, and that's why it's not done. So if we were to draw it in AutoCAD, the way the brick ledge is casted is you actually sit a 2x6 member across. Now we're only talking about the south here. We're not talking about what happens in the northern climates, but here in Houston, you're gonna have a 2x6. So what is the accurate size of a 2x6? An actual size? 1.5 inches by 5.5 inches. So when you have this 2x6 placed here, so in formwork, I'm going to draw the formwork in yellow to indicate how this foundation would be built. So these are the pieces of lumber, and then you have a stake that comes from here and that ties this directly to the ground, right? So this is what the concrete is being casted, right, guys? So concrete is being casted. All of these wood members then go away. This was the concrete. Okay? Go ahead and delete that. Control Z. So I'm going to go ahead and draw a line around this first. And I'm going to go ahead and delete all the wood members. And this is what you will be left with as a brick ledge. So that's where the brick would sit. Now, since the brick is 5.5 inches, 5.5 inches worth of ledge, what you will have is your brick being 3 inches wide, comma, 2 1/4. So that's where your brick is going to be sitting. The air gap behind it is where the air would flow through. Now, your slab has to go 3 inches below grade soil. Reason is because 3 inches is where our frost line is, and you need to be 3 inches below your frost line for your slab to not freeze over. If your slab freezes, then it cracks. So in that sense, you need to have your slab at least 6 inches deep. And most of the time, this is done by 2x8s. So this is where your slab will technically end in terms of depth. And then you have a grade beam that is associated with it. So the grade beam itself will be 18 inches, 18 or 24 inches usually. And this is on the perimeter of the slab. And sometimes this is also in the middle of the slab wherever you need support for your walls above. So I'm going to go, for the sake of reference, I'm going to go ahead and draw something that's roughly about this big. And I'm going to trim across. So these are the elements that I'm drawing right now. MA, property. Okay. So now we have our grade beam here. This is our slab. This will usually end up being a 45 because the dirt will move out of the way. But despite that, we have a 2x6 wall for our exterior that will start here. So in this case, it's going to be 1.5 inches, comma, 5.5 inches. So that's where our stud's going to go. Now I'm going to go ahead and put a X through the stud, and this will indicate that this stud is continuous. Now, on the inside of this house, you're going to have gypsum board. And gypsum board is usually held up about ½ inch away from the floor. And the reason for that is you don't want any moisture from the slab seeping through. Now, your gypsum board in modern time is about ½ inch wide. And if you were to look at it in terms of what happened in the past, you were be using a 5/8 inch gypsum board. So that's going to be our gypsum board. I'm gonna keep throwing everything into the wall layer, or I'm just gonna stay myself in the 0 layer, and we'll layer these properly right after I finish drawing this. So let me switch layers. So that's where your gypsum board is. The next thing I want you to understand is your baseboard. The whole job of a baseboard is to hide your flaws. So I'm going to go ahead and draw from 3/4 inch, and these vary. They can be anywhere from 3 inches to 5 inches. You can have baseboards, and you can even have a gallery finish where you can have a metal reveal here, and you can end up drawing this baseboard. And I'm going to go ahead and draw a baseboard at about roughly around 3 inches, and keep it a simple profile. I'm just going to say. So for the sake of reference, it's a 3 inch by ½ inch board, and I'm putting it here. So for those who don't understand what I'm talking about when I say baseboard, this is a baseboard. Baseboard is this on a wall. That's what baseboard is. So on the inside wall, all it's hiding is the gypsum board coming all the way to the bottom. Okay? Now when I say stud wall, this is what a stud wall is. So this is what's behind it, right? So this is the inside and going all the way to the outside. So, and then I'm going to talk to you about exterior sheathing. Exterior sheathing. Now, obviously, in this case, we're going to be looking at OSB plywood, but this could be anything from, we're going to be looking at OSB board, but it could be plywood, it could be any material specified by structural. Now in this case, since we're just covering up the wall, we're going to specify it as OSB plywood. Okay, so this highlighted is my gypsum board. This is what I can touch from the inside. This is the 2x6 stud wall. That wall extends up. That's the wall. And I'm going to keep this yellow. And I'm going to offset one more time, ½ inch. And this is my exterior sheathing. This is the plywood that goes on the outside. Now, between here, you have insulation. So, for the sake of telling you what that is, so this is what insulation looks like. So let me just go back. That's the pink stuff. That's the Pink Panther stuff. This is this. That gives you it gives you minor scratches, so your skin because it's literally, you know how you If you take sugar and you spin it and make cotton candy, if you take glass and you spin it, you make bad insulation. This is fiberglass. This is the same thing that your car, the outside of your car is made out of. You take fiberglass, you spin it, and it'll make bad insulation. So that's what this is. Now, right here is where your detail matters. Now, anytime water is coming down, understand that water will come through. Anytime water is coming down, what I like to recommend is doing a 12 mil vapor flashing that is self-adhesive. So I'm going to draw a PL, a line that does this. So this is a self-adhesive flashing. This is placed on the bottom. And guys, I want you to pay attention to this for just a little bit, because you guys need to understand this, because when we get to the next class, we're going to completely lose ourselves in Arc Design 2. So that's why this video is going to be available. So you have what's called house wrap, right? House wrap is this material, this Tyvek material that's on the wall. So for the sake of drawing reference, I'm going to give it a dimension. I'm going to offset only 1/4 inch, but in reality, this paper is 0.0001, right? It's 6 mil. It's like 0.006 in terms of thickness in inch, right? Because it's literally paper, right? That's what this paper is. And I'm going to make this a hidden line on purpose. Or I'm going to make it a gray line. Let's just switch the layers to gray. I'm going to make this a gray line on purpose so you understand what's going on. So this is the Tyvek paper. So this is your sheathing, which is the plywood. Then this is your Tyvek paper. What happens here is I want, how I like to detail my houses is I take a black tarp paper. This is either number 15 felt in the past, or nowadays it extends 1 feet off the stud. And this is your vapor barrier. So let me just show you what that looks like. So you see, when you have something like mold that happens on the ground like this is primarily because the water got in. This is the last thing you want in your house, okay? So in order to prevent this, you want your seams to be locked tight. Now, this detail varies. Nowadays, they're using spray foam, but this is still not effective because you can technically rot the wood. So So this is an example. Do you see this? This is like an underlayment that goes all the way to the bottom. I like to put this about 1 feet off the ground until it gets to that point. And I like to put that right behind the actual sheathing. The next thing I like to do is I like to put tape right through here that does this. Put it on top of the house wrap. And since its tape will hang out on the bottom, like so, I will literally hug the edges of this plywood. So now this edge of the plywood is literally encapsulated by this tape. Now, every time I have a nail or a screw that will drive through this plywood into the stud, it will literally be self-sealing. Now, when it comes to the brick, I'm assuming you're seeing this brick weeps. How many people have seen this around your house and have no idea what these are? Someone left a gap there. How many times people look at that or like this? A weep hole. There's a purpose to it. So when water gets behind the brick, because brick itself is a cementitious product, it will absorb water. 3/8. So if the water gets back here, right, and water transfers through, it'll hit this paper and it'll percolate, and it'll come all the way down here and it'll pull, and it'll cause mold. In order to prevent that, every 16 to 24 inches, you're supposed to have a weep hole. Weep hole allows for water, air, pretty much allows the brick to dry. Air can circulate back there, water can escape if it needs to, and even though this has humidity that will build up behind here, it'll weep out. And this is how a brick wall would be detailed, right? So this is what it would do at the foundation. Now, taking the same detail, copying it over, and we're going to talk about fiber cement. And this is going to be a very quick detail. I'm going to go ahead and get rid of all the brick. Stretch the wall out. And make it attach here. Nothing changes. Only thing that changes is all of the plywood will stop here, and your fiber cement, which goes on top, will extend down 1 1/4 inch. So your siding will technically do this. All right. So as we finish out this video, all I'm going to show you is how to represent fiber cement siding. I'm going to go ahead and drop it. I'm going to go ahead and draw 1.25 inches in terms of width, because this board is sideways, and you're going to connect 7 1/4. .25, and you're going to connect back at every 8 inches. So this is what your connection would look like when it comes to your siding. You'll simply copy this up. Representation of your siding. And that is how siding is in relative to your foundation. It has to be 1 1/4 inch from your foundation, the top of slab, and then recommended 6 inches by code, but 8 inches is what is standard in most office, from the edge of the siding to where the top of soil is. So the side of your foundation should be exposed and the soil slopes away. So as you're looking at your final wall section detail at slab, you're looking at a slab that ends like so, You have a grade beam. You have a slab that goes beyond the frost line, and in Houston, you're looking at beyond 3 inches from base level, and looking at a 6-inch height difference. When it comes to brick ledge, similar situation. You have a 2x6 that is casted to allow the brick ledge to sit slightly lower than the actual wall. You allow for the wall to breathe out from the bottom and water to escape. So these are the most typical conditions that you will find in residential construction. And if you were to switch out the siding with stucco, besides the house wrap, you will need a second grade D paper or a drainage layer, but it will be detailed the same way. And stucco will be pretty much at slab condition, will behave the same way as the siding. With that, I'm going to go ahead and end the recording. Please like, subscribe, comment below.